In this video we're going to be looking at Lewis structures that involve multiple bonds, and in particular those that cause a situation called resonance. So the example that I want to start off with is sulfur dioxide, or SO2. Now sulfur and oxygen are both in group 6, so I have 3 atoms in group 6, and that'll give me 18 total electrons. We'll put the sulfur in the center, and the 2 bonds will use up 4 electrons, leaving 14 electrons left over. I'll start on the outside with the oxygens, and each of those oxygens are going to need 6 more electrons. Since I've just used up 12 electrons out of the 14 I have remaining, that's going to leave 2 left over that will go on the sulfur. But when we take a look at sulfur, sulfur is only surrounded by 6 valence electrons. So we're going to have to do some sharing. I'm going to take off the electrons from underneath the left oxygen, and we're going to turn that into a double bond. Now you may be looking at this and thinking to yourself, seems like I could have also have done that on the right hand side and had the double bond on the right hand side. In other words, you might have a structure that ended up looking like this. So, which one of these 2 structures is the correct structure? Well, it turns out that the answer is neither of the 2 structures is correct. When we take a look at models that you use in science, one of the things that you have to accept is that models are not perfect. They're always going to be an incomplete representation of nature. And so this is a limitation for this model in that it doesn't do justice to this particular molecule and many others that are like this. When there's more than one place where you can put a multiple bond, it turns out that when scientists take a look and investigate this molecule and do some analysis on it, they find that instead of having a double bond on the left or a double bond on the right, what you always seem to get is you always seem to get 1.5 bonds on each side. So it's really an average of the 2. But there's no real way in this model to show a 1.5 bond. So what we're going to do is, with this model, we're going to draw all the possible structures, and we're just going to separate them by a double-headed arrow. And it's up for the reader to understand that what this means is that of all the different possible Lewis structures that you can draw, what you have to do is you have to just kind of average out all the different possibilities, and that's what the real answer looks like. So resonance refers to the condition when more than one Lewis structure can be drawn based upon where you're putting double bonds or triple bonds. And this is a fundamental limitation for the Lewis dot diagram model, and so it does not accurately depict what the structure is no matter what you do. So the best that this model can do is to say draw all the valid structures, separate them with a double-headed arrow, and then the reader is just left to understand that the true structure is really just an average of all the different possibilities. Let's try one last example to wrap this up. We're going to do carbon dioxide. So carbon's in group 4, oxygen's in group 6, but there are 2 of those. That's going to give us 16 valence electrons. We'll put carbon in the center, surrounded by the oxygens. There goes 4 electrons from the bonds. That leaves 12 electrons. The oxygens are going to need 6 more electrons to get up to an octet. That uses up the remaining 12 electrons. No electrons left. As we turn our attention to the one we always do last, which is the central atom, we notice that carbon only is surrounded by 4 valence electrons. What can we do? Well, let's take off some electrons, and we're going to do that on both sides. And by turning those unshared pairs now into shared pairs or bonding pairs, we have gotten carbon up to 8 valence electrons, And if you go back and take a look at the oxygens, they're still at the 8 valence electrons as well. Now, is there another way we could have done this besides putting 2 double bonds? Let's return to the structure before we started making multiple bonds. What if we put a triple bond on the left-hand side? So if I shared once, that gives me a double bond, and if I share twice, that's going to give me a triple bond. Now when we take a look at it, you can see that the carbon in the center also got up to 8 valence electrons. Oxygen on the left, the 3 bonds gets you up to 6, and the unshared pair gets you to 8 electrons, and the oxygen on the right-hand side was still at its 8 valence electrons. So that's a second structure, and the third structure is just going to have the triple bond on the right-hand side. And so carbon dioxide has 3 valid Lewis structures, and you're going to have to show all 3 of those resonance structures.